Welcome to Lesson 312, Creating Expressions. Today we're going to talk about how to write expressions from phrases and how to write expressions from word problems. So the first thing I want to talk about is when we use different languages, we know that if I speak Spanish to you and you are only an English-speaking person, that you're not going to be able to understand what I'm saying, and I'm going to have to translate it into your language. Okay, so this happens with math as well. So if I have something written as a phrase in words, as a mathematician, we like to look at them in numbers so we can solve them. This is particularly true for word problems. So the first thing we need to look at is what each of these pieces are. So a numerical expression is a mathematical phrase with only numbers and operation symbols. So an expression, we've talked about this before, does not have an equal sign, but an expression is anything like 5 plus 7 or 10 minus 12. Okay, so all it has is numbers and then your operation symbols. It does not have a solution, it's just the expression, it's just the problem. A variable is a letter that can represent one or more numbers that can change. So when we have like the formula area equals length times height, or length times width, each of those letters, we usually say A equals L times W. Each of these are variables because the length can change, the width can change, and the area can always change. Okay, so we can use this as our example, or if you want to write 5 plus y, and then circle that y as your variable. It's up to you. But an algebraic expression, now this is how I remember this. Algebraic has an A, as does the alphabet. So when you have part of the alphabet in your expression, it's algebraic. A mathematical expression with one or more variables. So when I involve the alphabet, or these letters, into my expression, it becomes algebraic. So this is like saying length times 4. Okay, so that would be an algebraic expression because you have the variable L for length times 4. And evaluate. We don't talk about this a lot, but you see it a lot. Evaluate, okay, is when you substitute for each variable and use the order of operations to solve. Okay, so really evaluate means solve when we're talking about solving a problem. All right. Now that we know what kinds of expressions there are, we're going to take a look at numerical expressions. And we're going to look at what words we use with each operation. So if I'm talking about addition, okay, and you have this in your notes, it's spread out quite a bit more for you, so you have more room to write. So please make sure to get these written down. The order does matter when we write things down. Now I know with addition we talk about being able to interchange it, but I want you to practice writing it the correct way, because if we say 32 added to 18, that's not the case. The first number that we're given is always what we're adding to. It's always what we have. So I have 32 and I'm adding 18 to that 32. Okay, so I believe that's here. Okay, 18 added to 32. And the reason I want us to practice this is because subtraction and division absolutely have to be in the correct order. Addition and multiplication you can move around, okay, due to all the multiplication and addition properties and get the same answer. However, subtraction and division, you would not get the same answer. Okay, so added to is one of the forms that we have. We also know that plus is a word for addition. And we know that the answer to an addition problem is the sum, so we say the sum of 32 and 18. Again, 32 is written first and 18 second. Okay, it's only switched around when we're adding to something or subtracting from something. And then here we have 18 more than 32. So you have 32 and you want 18 more. Okay, so it's not always going to be the exact same order. Subtraction, so we have a bunch of different words here as well. So we have 90 subtracted by 12. So when you're doing subtracted by, you're taking what is being subtracted by what is being subtracted. So if you said 12 subtracted by 90, that would actually mean this. Okay, so it's 90, that's what you're starting with, subtracted by, so you're doing that to the 90, 12. Your next one, 90 minus 12. I think we're all very familiar with that one. Then we have the difference of 90 and 12. Okay, again, written in the same order. 12 less than 90. So if you say 90 less than 12, that means you're going the other way on the number line. You're starting at 12 and you're going 90 backwards. You're going to end up with a negative number. But if you say 12 less than 90, which is what we're looking for because we're starting with 90 and we want 12 less. Take away 12 from 90. So really when you're using the words subtracted by, less than, and take away, that's when we're flipping our numbers around. Multiplication. We've seen a lot of these words as well. So 8 times 28. Seen that one before. 8 multiplied by 28. The product of 8 and 28. And 28 groups of 8. Okay, now we have 327 divided by 3. Again, if we switch those around, we are going to get the incorrect answer. And the quotient of 327 and 3. Okay, please make sure that you have all of these written down. If you need to, take a minute to pause and go over them. Alright, so what I'd like you to do, I'd like you to write as many, or I'd like you to take the phrase and change it to an expression. So in this case, we have two numbers, so it's going to be a numerical expression. So I have 287 plus 932. If I look back here, plus, I know that it's going to stay in the same order because it's not changing the way it works at all. So we have 287 plus 932. And then we have 4 groups of Q. I know groups of takes me to multiplication. So I want to use the multiplication sign. Now I can do this several ways. I can do this. I can write it like this. Or I can write it like this. All of these mean the same thing. And then of course this. Any one of those 4 would work. They all mean the same thing. Now, here's where the tricky part comes in. Here we have 25 less than h. Less than h, so this means that h has to be bigger because it's less than h. So h is my bigger quantity, and I want 25 less than that. So whatever I get here as my answer has to be less than h. And in order for that to happen, h has to be my biggest number. Okay. So now you have these 3 problems down here. I want you to try and write your own expressions. And when you come back, we'll check your answer. Alright, so we have the quotient of c and 2. So c divided by 2. 2 less than the quotient of d and 16. So now here's the 3-piece one. 2 less than. So that means that whatever I get, I want 2 less than that. So 2 less than, this whole piece has to go together. The quotient of d and 16. So I have d and 6 divided by 16. And whatever this is, I want 2 less than that. So whatever I get for an answer has to be less than whatever d divided by 16 is. And if you go back here and you check, less than always means that we have to flip our numbers around. In this case, it wasn't just numbers, it was an operation, a quantity. 17 more than, so again, more than tells me that this is going to go at the end, the product of 3 and m. So whatever 3 times m is, I want 17 more than that. And this takes a lot of practice, and it takes a lot of practice not only with math but also with language arts and just understanding what words mean and how semantics and word order are really important, especially when it comes to putting things in order for math. Alright, so now we're going to look at how to use this with a word problem. So the Nile River is the world's longest river. Let N stand for the length of the Nile. The Amazon River is the 4,000 miles long. Write an expression to show how much longer the Nile is than the Amazon. Okay, so in this case, we want to highlight the important information. Okay, so these would be, so if you look at this, it's kind of like saying, here's your main idea. Writing an expression. Okay, so write an expression to show how much longer the Nile is than the Amazon. So we're not solving this, we just want an expression. Now our supporting details would be that the Amazon is 4,000 miles long, and that the Nile is n miles long. Okay, now this right here, the Nile River is the world's longest river. The only way that that helps us is by telling us that n has to be bigger than 4,000. So to write an expression to tell us how much longer one is than the other, well, if I ran 5 miles and you ran 4 miles, we would do 5 minus 4 to say I ran 1 more mile than you did. Same idea, except for in this case we don't have a number. So we have to take the longer river, which in this case is the Nile, and we're going to subtract from the Nile the Amazon. And from that, that's going to tell us how much longer the Nile is than the Amazon. So now let's put in numbers for our rivers. In this case, the Nile is represented by n. So we're making an algebraic expression because we have a variable in for the Nile. And the Amazon River is 4,000. So our expression is n minus 4,000. Alright, so for the last part of your work, I would like you to try these 3 problems. Each one of them asks you just to write an expression to find, in this case, the width, to describe the relationship, okay, and to talk about Jane's share of the rent. You need to read very carefully, and you need to make sure that you know what each piece of information represents. I would strongly suggest having your highlighters, finding those questions, the supporting details. As always, if you have any questions, please be sure to post them to Edmodo.